Welcome, Doctor.
Okay. So yeah, waiting for a few more people to come in. Have you guys ready? So today we're going to have your presentation. I'm checking out all this thing. Okay, I'll be back. Okay, 72. Okay, 74. Keep coming, keep coming. Hai Anissa. Bagus Anissa buka video. Ni kan gelak, gelita je semua orang. Segan pula Anissa ni ada lari. Okay. Okay, let me just brief what is going to happen for this 1.5 hours. Okay. So, okay. Hopefully you are there, even though you didn't say anything. Okay. Today's host will be Zaza. Who's the host today? Jianti, right? Jianti, are you there? Okay. So today, what we're gonna do, like we have the topic. Last time we have discussed, we have taken your topic. Okay. So we are going to start with okay, we know that carbohydrates they are divided into 3 parts, like monosaccharide, disaccharide and polysaccharide. So now we are going to have a look at the structure of each of these carbohydrates, and then after that what is so important here, you need to focus on the structure and then how it it can be detected, hopefully in a complex mixture. Not so much on that, but more like a structure and then the function, where can we find all of these, it is used for what kind of reaction can be formed, what kind of enzyme can be used to cut all of these carbohydrates. Okay, so now we will go to why don't we take the glucose? Why do we take off glucose? Because you can see glucose is the basic one, and then along the way, while you are presenting your starch or your sucrose or even your galactose, glucose will always come to the discussion all the time. Okay, even for maltose. Okay, so these two things, they are like similar. One is monosaccharide, one is disaccharide, but the building block, they are similar. Okay, so we will start with the first presentation. You may share your screen. You'll be given like 8 minutes. It's up to you. How do you want to make it happen? But just optimize the time for 8 minutes, and then hopefully we can take 1 or 2 questions from the students, from other students. And then after that, we are going to proceed with the next topic. Okay, so today I think we can start with monosaccharide first. We are going to have K1G1 and then later monosaccharide. Okay, K1G1. Okay, we will start with fructose from K1G1, and then we are going to have K2G6. Where these two groups, they will be presenting the topics on the fructose. The information may be similar, but there must be like some additional point covered by K2G6, and then maybe some may be covered from K1G1, right? K1G1 for fructose. Okay, so let me go for this slide first. The intro. Okay. We will. Are you ready? K1G1 or maybe K2G6 just now? As long as your topic is on fructose, then we'll be good. Okay, we're going to start with fructose first. Let's see the basic structure of all of this, and then after that we go for glucose, and then lactose, sucrose, starch, fiber, and casein. Okay, so you may share the screen. Okay, this is from what? K1G1 or?
K1G1, doctor.
Okay, K1G1, you may share your full screen, your slideshow. Others, please take note, and then because I'm not going to repeat the lecture for whatever you have shared today and on Wednesday. What happened? This is going to be part of your test too. Okay, don't expect I'm going to be baby like normal. So you're going to have different kind of presentation for your friends. So these are basically the notes that you are looking for. Okay, so please start.
Okay, can you guys see the screen?
Yes.
Okay.
Yes.
So, Angeline?
Yes, I can see. Okay, good afternoon, everyone. So we are from K1G1, and we would like to present to you our carbohydrate, which is fructose.
So what is fructose? Fructose or fruit sugar is a simple ketonic monosaccharide which we can call ketohistose too. It found in many plants.
Someone need to turn off your microphone because I can see the blender. I can hear the blender sound or what? And Husna, if you are talking now, can you please make it louder or use microphone? You sound like you are really far away.
Hello, can you hear me?
Yes, but not so clear. Can you make it louder? Or are you okay?
Husna?
Wow, too many technicians. They are all helping you, Husna. Go, Husna, go.
Okay, hello.
Are we good, Husna?
Hello.
We can't hear you. Or maybe other people from this group can can present, like
Okay, I will be presenting instead of Husna.
okay.
So as you can see, fructose, it's a simple ketonic monosaccharide. And it cannot be further reduced to a simpler compound because fructose is already a monosaccharide, which means it has only it is a monomer, so it cannot be reduced, and it is often bounded with glucose to form sucrose. So when fructose and glucose it is bonded together, it will form sucrose, which is a disaccharide.
Okay, next is structure of fructose. I will present the structure of fructose. Okay, 6-carbon linear chain with hydroxyl and carbonyl group is a fructose structure. Okay, most of it exists as two hemiketal ring, which is beta D fructopyranose and beta D fructofuranose. In aqueous solution, there is 70% of pyranose and 22% of furanose. The smaller amount of linear and the other is cyclic form. So we can see from the 70% of pyranose and 22% of furanose, there is 98% of cyclic form. And then the other may be 80%, 8% like that is the amount of the linear form. Okay, so we can see here there is a structure of fructose that we common seen. Actually, if we first year learn from metric or asasi or diploma, maybe the common structure that we have seen is this structure. This structure is named beta D fructofuranose. So how we want to know the name and the structure it is, so I will show it at the next slide. So next slide. Okay. Okay, this slide, you can see there is 4 different structure, which is alpha D fructopyranose, beta D fructopyranose, and then alpha D fructofuranose, and also beta D fructofuranose. Okay. Firstly, actually, we have to know whether it's pyranose or whether it's furanose. So you can see from the bottom right, there is structure of pyrene and furan. Pyrene is the consists of 1, 2, 3, 4, 5 carbon with the 1 oxygen atom in the ring structure. And for furan, there is 1, 2, 3, 4 carbon with the oxygen atom in the ring. So it is furan. Okay. In terms of alpha, beta refer to the configuration of the anomeric OH group. Okay. So you guys can see from the structure, if the OH group pointing down at the carbon 2, so it is alpha. But when the OH group pointed up is beta. So I think that's it. Yeah, for the structure.
Okay, continue with the classification. Okay, fructose is a ketonic monosaccharide, which is ketohexose, consists of simple sugar. Okay, basically all monosaccharide are hexose, which means they have 6 carbon atom in its molecule. Specifically for fructose, it's a ketohexose because it possesses a ketone functional group in its structure. Ketone is one of the chemical compound that give the sweet taste. Okay. chemical formula for all hexoses is 6 carbon, hydrogen 12 and oxygen 6. It fructose have low molecular weight, soluble in water, taste sweet. Fructose is the sweetest of all naturally occurring carbohydrate, which is galactose and glucose, due to its stereoisomerism or hydrogen bond. It have melting point of 103 degrees, density of 9.69 gram per kilo. That's all.
Okay, as for the naming, fructose we can name it in three ways. One is through its IUPAC name, which is 13456 pentahydroxy hex 2 on. So as you see the structure, you can see there's 6 carbon, and it is a ketone structure, and that is why there is hex 2 on. And you can see there is hydroxyl group in carbon 1, 3, 4, 5, and 6, and that is why it's pentahydroxy. So secondly, you can name it as fruit sugar because, as Iqlil said just now, fructose is you can found abundance of fructose in fruits, and that is why it can be said as fruit sugar. And it is a monosaccharide. And the last is its levulose. Levulose is another name of fructose because it is a left rotation of stereoisomer of fructose, and it rotates the plane of polarization of the light to the left. So that's about the naming.
Okay, this shows the sources of fructose that we can get. So fructose can get from natural sources such as fruits and vegetables and also honey. And then the highest dietary sources means that the food that we can get the high amount of fructose is like pure crystalline fructose, food containing table sugar, high fructose corn syrup, agave nectar, honey, molasses, maple syrup, fruit and fruit juices. So molasses is a type of sweetener that is the product from the refining of sugarcane, and agave nectar is sweetener commercially produced from several species of agave. Okay, so maple syrup is made up from the xylem sap of sugar, maple, red maple, and also black maple trees. Okay, next. This table shows the sugar content of in some common plants, fruits such as fruits, vegetables, and also grains. So you can take a look at it. Okay. So the next is carbohydrate content in some commercial sweeteners. So the HFCS is actually the high fructose corn syrup. It is a type of sweetener derived from corn syrup, and it has replaced sucrose to become sweetener because it is easier to use and is cheaper. So the number behind the HFCS is actually the percentage of fructose found in the corn syrup. 42 means there is 42% of fructose can be found in the fructose corn syrup. Okay, that's it.
Hi everyone, my name is Pinesh Prasad. So I'll be explaining about the functions and importance of fructose. So there are three types of function. We have divided into three. So function of fructose in human body, function of fructose in plants, and the last one is role of fructose in food industry. The function of fructose in human body and plants will be explained by me, and the role of fructose in food industry will be explained by Suganti. Role of fructose in human body. First of all, normally glucose is the one provides energy in organisms like us. So if in this case provides energy when glucose is not sufficient, while the metabolic energy demand is high, meaning the glucose is not sufficient. At the same time, the metabolic energy is high. So what happens here is fructose is the one going to being oxidized and provide energy to the cells. And the next point is source of energy for sperm motility. As we know, sperm has to swim through uterus and fallopian tube until they reach the egg and undergo fertilization. So at this point, for the sperm to swim, it requires energy, and fructose is one of the major source which supplies the energy for the sperm. And the last one is fructans. Fructans with low degree of polymerization are promoted as a soluble dietary fiber in the small intestine, but stimulate growth of beneficial microbes in the large intestine. Okay, first of all, what is fructans? Fructans is a polymer, meaning its monomers is fructose. So the fructose, each fructose are connected with a glycosidic bond and form these low degree polymers. So these polymers, we call them as fibers. So as previously mentioned, we get fructose from fruits, right? So the fruits, we normally say them as fibers, which are not, can't be digested by our body. So those fibers are actually the fructans. And in large intestine, these fructans stimulate the growth of beneficial microbes in our large intestine, which can help in breakdown of carbohydrates. And the next one is role of fructose in plants. So as we know, normally if we say plants, energy reserve will be starch. But in this case, these vegetables or fruits, when they are at the early stage, like consider seeds or bulbs, onion bulbs, fructose will be the major source for the plants to get energy. And the next point is fruit bearing plants convert glucose into fructose, which is the natural sugar that gives most fruits their sweetness, previously explained. And the third point is plants use their sugars as a lure to animals to ensure their own survivability. This means that plants have fructose that attracts the animals and also humans, because to germinate their seeds, this is technically kind of attracting the animals and humans, and make them, if in our case, if it is humans, we tend to plant the fruits and vegetables, and this is a type of germination of the plants, making them to ensure the survival of their species. And the last one is fructan. Fructan plays role in regulation of osmotic pressure, sink strength, and resistance to cold and drought. Sink strength meaning the condition of the bulb, which I previously mentioned, where the sink strength is high, meaning the bulb of onions or other kind of vegetables or fruits is providing fructose to the plants to survive.
Hello guys, my name is Suganti, and I will be explaining about role of fructose in food industry. So in food industry, normally fructose is hygroscopic, which is attracts for water, and it also serves as a good humidifying agent, which is good moisturizing agent for baked goods, biscuits, and confectionery. Confectionery is such as sweets, and then it also acts as sweetener ingredient, which usage of high fructose can reduce the calories. Next, texture and enhancement. It gives longer shelf life to many products, as fructose doesn't hydrolyze in the same way as sucrose. Next, moisture. It retains moisture and texture in products that are looking for soft, moist, and consistent texture, as it can fructose can bind moisture well. And color and flavor development. Fructose provides a nice mouth feel in products, and it can give a browning effect when heated. And fructose also has a low glycemic quality than other sugars. That's all. Thank you.
Okay, thank you.
From
Okay,
our group. Thank you.
I want to find exactly some of the fructose just now. I think you need to have like a label. This is carbon 1, carbon 2, carbon 3. You know, you have only the second structure of it. Yeah, you have only this. So I think you need to have in the cyclic form, like the earlier part, the what? I can't remember. Yeah, here. I think it is nice to label from for to pyranose, and then this is carbon 1, carbon 2. You know the naming of it. Okay, so okay, let's just listen to the second presenter from K2 first so that we can have more information before we throw the questions? Okay, thank you, K1G1. The second presenter, please share your screen. You need to have only 10 minutes maximum, guys. Yeah, that's why, because this is important notes. You don't want to, you want to have people to understand about this topic, right? So make it interesting a little bit, and then hopefully just stick to the time, 8 minutes or 10 minutes maximum. Okay, so K2, please.
Sekejap.
It's K2G6, right? So later we are going to have the second carbohydrate, which is galactose. Okay, we want to see galactose. What is the
Can you all
difference
see the
between
screen?
galactose? No, we cannot see your screen yet. Okay, on the way. No slide. Nina?
Sekejap. Okay, can you guys see now? No.
No.
Tak boleh lagi?
Tak boleh, tak nampak lagi.
Kenapa tak boleh?
What happened?
Nina line macam lag. You use
Saya pun
Firefox.
tak sure kenapa tak boleh.
Nothing, Nina.
Probably you need to drag the
Not lag,
window with the Google Slides as a new window.
Nina, what's happening?
Okay.
No, not working, Nina.
Kalim, can you share the screen? I think it's lag lah. I think my laptop is lag.
Okay. Anyone in from the group? Do you have it? The slide or only Nina?
Sekejap.
Or else we move to the second group. I mean the second topic first. Then we come back to your group. Can we have lactose first? Lactose, and then get ready
Doctor.
lactose, sucrose, and then all the polysaccharides.
Doktor dah ada.
Okay. Let me check quickly. Okay. Still loading. Okay.
So this is our group. We are from group K2G6, and our topic is fructose. So for the definition of fructose, the first is it is a ketose hexone a monosaccharide with a chemical formula of C6H12O6. And this is the sweetest carbohydrate among in the nature, and it can be combined with glucose to form disaccharide sucrose. And for sucrose, an in organ in this is an organic compound with molar mass of 180.6 gram per mole, and the melting point of the fructose is 103, which is slightly higher than water, and it can be crystallized, water soluble, and it is very sweet in tasting.
Okay, Kanin, what happened?
The next person, okay. This is the structure of the fructose. In in the case of the fructose, there are five member ring is formed. The OH on carbon number 5 is converted into ethyl linkage, which are very strong, is close to the ring with carbon number 2. This makes uh, a 5-member ring, 4 carbon and 1 oxygen, which means it's a penta sugar, pentose. So next one.
For the classification, the most useful classification, it divides the carbohydrate into groups according to the number of individual simple sugar units. So monosaccharides contain a single unit of sugar. Disaccharides contain 2 sugar units that is bonded by glycosidic linkage. And polysaccharides contain many sugar units as in polymers. And then below is a table that classify carbohydrates, and we can see that fructose is classified as a monosaccharide, which contain only a single unit of sugar. That is all for classification.
Okay, next for the naming. The name fructose was first created by William Allen Miller in 1897, and the IUPAC name is 3S for art 13456 pentahydroxyhexane 2-one, and the other name fructose is fruit sugar, levulose, defructofurunose, defructose, and the arabinohexulose. Okay, next. Okay, where can we find fructose? So these are the sources that we can find fructose in them, which are fruits, sugarcane, starch, and honey. Next, next is
Okay, the
I give.
Okay, the biological function of fructose. For fructose, it can form a fructose polymer, which is called fructan, which serve as a storage polysaccharide that present in grass, asparagus, and leeks, and is also present in onion. Fructose as a basic unit of sucrose, which is white sugar, the table sugar we normally eat, and it normally is the fructose is linked with glucose through alpha linkage. For fructose in biological function, it can act as a alternative metabolite in providing energy when it's not enough glucose. Example in cellular respiration, it can involve in glycolysis by entering the glycolysis cycle as if the glucose is not is not enough. So fructose can be also modified to produce the lipogenic precursor for to fat synthesis. Therefore, we know that we shouldn't consume a lot of fructose. If not, the high amount of sugar fructose will initiate the fat synthesis precursor and causing us to become fat. And it also catalyze the glucose uptake and storage in our liver. So that's all for our presentation. Thank you, everyone.
Okay, thank you, K2G6. Okay, still, both of fructose group. I wonder, okay, how do you name the carbons? Because it's important to know the carbons of each. Can you go back to your slide just now, like the one with the ring, the pentose sugar? Can you share again your slide, Kalin?
Slide.
Okay, so where is carbon number 1, number 2, number 3, and then where is the functional group? What can be detected, and then how it can be detected in the lab, you know, to classify this is fructose, how it is different than the other sugar. Okay, so from here, where is carbon number 1, number 2, number 3, number 4, and number 6? Even K1G1, you can help to explain since both of you are having the same topic.
So, doctor, I think. Wait, where's my mark?
We can see your cursor now. That's okay. You can use the cursor, the pointer just now.
So we can see that for my personal point of view,
your personal point of view. Need a solid answer, not your points.
Okay. What I think is this is the carbon number 1, 2, 3, 4.
No. CH2 is the carbon number 1.
Which one?
Left
or right?
Right. And then at OH, attached to OH.
Is it this one?
No, right. There is left, right.
That's
on the right. Okay. CH2 attached to the OH.
Okay, maybe Afrina, you can show your screen, or are you on the same group, or are you K1G1?
K1G1.
Okay, go to your presentation. If you have your slide, then it will be easier. This is important, guys. Once you know where is the position 1, 2, 3, 4, 5, 6, and then you know the relation between the polysaccharide, monosaccharide and disaccharide later. Otherwise, you don't know where is 1, 2 beta linkage or what, 1, 4, 1, 6. And then how can we detect all of yeah, you can go for this. Yeah, this one looks nice.
Okay.
Okay.
Here, CH2OH. This is carbon number 1. And then it's attached to carbon number 2. And then attached to carbon number 3. And then carbon number 4. Carbon number 5. And then carbon number 6.
Okay, then that one is beta D fructopyranose, right? So
Yeah.
for alpha?
Okay, for alpha, if the OH group O or the number of carbon. You want to know the number of carbon or the OH group?
No, I want to know where is carbon number 1, number 2.
Okay, the carbon number 1 is at CH2. That attached to OH and then attached to carbon number 2 and then attached to carbon number 3 and then attached to carbon number 4 and then attached to carbon number 5 and then carbon number 6.
Okay. Okay, thank you, K1G1. And then where is the functional group? How can we detect the presence of fructose in the lab? What kind of test can be used? And then what kind of group in the structure being detected by that kind of test?
The functional group is hydroxyl group and the carbonyl group.
Where?
Where? Is the OH OH is the hydroxyl group, and then the ring structure with O is the carbonyl group.
Really? How do we detect that in the lab? How do we detect the presence of fructose in the lab?
How do we detect?
Okay, go to your slide number 6. You have naming there. Slide number 6. Even your spelling, classification. Come on, guys. There are 6 of you. Okay, so where is the functional group here?
The functional group. The functional group here. Okay, D-fructose. The functional group, we can see there is ketone. See at the carbon number 2 attached to the oxygen with the double bond. So it is ketone.
What will be?
Ketone. Ketone.
Okay. So that means this is the functional group for fructose, right?
Yes.
Because it is a ketone sugar. Okay. So yeah, this kind of information that we need to know more. And then after that, when we move to the second, which is if you move to the disaccharide, then we can see the continuation from the basic to the di. This is where they link, how they are linked together, right? Okay, so can you go back to your slide number 5 just now, K1G1? Yeah, this one. How do you spell classification? Is this correct? How many of you guys? This is really, I don't know. You just do it like acho tak acho or what? Okay. So please, okay. I think that's it. Thank you, K1G1 and K2G6, both of you. Okay. Later, just improve the slide. Whatever typo and then comments I gave just now, put it nicely, and then I'm going to, you can email me so that I can share to all of you, or even you can put it in your general channel. You see, this is from K1G1 notes, K2G2 about fructose, or K what? You know, K1G1 fructose. And then everybody can have a look at the notes with the improved version. Okay, so can we have the second topic, for the galactose? Who's doing galactose? Maybe we go for K2 first. Galactose K2G1.
Okay, sure. Wait a second.
Okay.
Can you guys see my screen?
Yes.
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 Okay, so good afternoon, everyone. We are from K2G1 and we are going to present galactose today. So first of all, we are going to start with the brief definition on galactose.
Yeah, who's speaking?
And see.
Huh? What happened? Who's presenting?
Should be
Binturo Hitam. Who is Binturo Hitam?
It's
He has a problem with his microphone.
Okay. Other people from K2G1. Kalista?
Okay. So
maybe I'll go for it.
okay, sure.
Okay. So here's a brief definition of what galactose is. So it is the simplest sugar. So we know that simple sugar, there's 3 that we know, which is fructose, glucose, and also galactose. So we are presenting on galactose. Then there's no hydrolation occur afterwards.
because it's already the simplest form, so you can't do any hydrolysis anymore. And it is also a monomer to build a polysaccharide or disaccharide. Then, yes, the same thing. Then, complex and simple carbohydrates. It's something that I just explained just now. And it is also energy source for respiration. That's the definition. So move on to the next one.
Okay, so for the structure of galactose, so galactose is a monosaccharide and has the same chemical formula as glucose, which is 6,6, H12, and O6. It can exist in open chain as well as cyclic form. In the chain form has similar pattern like glucose, like we see in this slide. It has the similar structure with glucose. Glucose and galactose is stereoisomer, which mean they are the atoms are bonded together in the same order but differently arranged in space. Like we see, the OH group on carbon number 4 of galactose is on upward projection, while galactose in downward projection. It is similar to glucose in its structure, like what I said just now, is just different only in the position of one hydroxyl group. And that's all. After the next one.
Again, Haja, where is it? Carbon number 1, 2, 3, 4?
Carbon number 1, like at the CH2OH, that's the carbon number 1.
Okay.
Then we move to the carbon number 2, which is from the left. Carbon number 2, number 3, down, number 4, and number 5. Number 5 is the most right position at a ring structure.
Okay. So that means the CH2OH green color is number 6, right? Carbon number 6, right?
Yeah.
Yeah. The problem just now, Haja is presenting, but Kalista is pointing at different position. That's why I got confused.
Oh, okay.
Sorry.
How that one can be carbon number 4, but it is carbon
I
number
kira salah number 4.
Okay, guys, the whole class, please delete the previous one. Okay, replace with the new information. Okay. So Hajar, you can proceed.
Alright guys, I'll continue with classification as well. So galactose can be classified under a few different types. First is of course monosaccharide, as we know. Second is it can be classified as hexose. It's quite pretty forward because O stands for simple sugars and then hex stands for 6, and that 6 refers to carbon atoms. So galactose is a 6 carbon sugar. Then the second one is aldohexose. So aldohexose, as you see the name, hexose, you know what it means. I just explained just now. And then aldo stands for aldehyde group. So I'll explain it. Maybe I'll see the definition here. So aldohexose is a hexose with an aldehyde group. I explain it in the next slide. Okay. So here's the difference between an aldohexose and also a ketohexose. So if you guys do not know what is an aldehyde group and ketone group, let me explain. Both aldehyde and ketone group are considered carbonyl group. Carbonyl group is actually C double bond to an O. Kaisa, can you show it? All right. Okay. So how do we differentiate an aldehyde and a ketone? So here's a differentiation, comparison between glucose, galactose, and also fructose. If you see glucose and galactose, the C double bond is at the terminal or at the end. So it has an additional H attached to the C. So we have C double bond to O and a H. So it's a CHO, therefore it's an aldehyde group. All right. So same goes to glucose. It's the same thing. So both glucose and galactose are aldohexose. But as for fructose, you can see the carbonyl group is at the second carbon. It's not at the terminal. So when it's at the second carbon, you can see the C is already bonded to two of its bonds are already bonded to O, one of it to the C at the bottom, to the third carbon, and another one is bonded to the first carbon. So the C is already occupied with 4 bonds, therefore it cannot attach to additional H. So that's a C double bond alone. Therefore, fructose has a ketone group instead of aldehyde group. So fructose is a ketohexose and not aldohexose. Yeah, that's it.
Okay, so next is for the naming for the galactose. For the naming, galactose IUPAC name can be based on the IUPAC name 2,3,4,5,6 pentahydroxyhexanol, or we can call as aldehydo-D-galactose because it contains the aldehyde group, and or aldohexose because it has 6 carbon. So for the words galact from galactose is means milk in the Greek, and while for the O's it indicates for the sugars, or in short we can call as gal.
All right. So this is the source of for the galactose in food. I've listed top 5 food that contain galactose. So for the first one, we have a low-fat Greek yogurt, which contain almost 6% of the galactose percentage. And the second one is cherries, 0.6 also. And then the third one is honey, which contain the most higher number of galactose, which is 3.1%. And then we have kiwi fruit, it contains 0.2%. And the last one is low-fat mozzarella, 0.8%. Yes, that's all.
Okay, the next one is the function of galactose. So I choose 3. So the first one, galactose is the basic substrate for the biosynthesis of many macromolecules in the body. So the second one is act as energy providing nutrient, especially for the early development stage of mammalian infant. This means they feed on the milk, and then they will get the energy providing nutrients. And then the third one is galactose is useful in removing neurotoxic compound from the brain in the patient that's suffering from Alzheimer disease. Alzheimer disease is something that we call as penyakit nyanyok that usually happen in old people. Okay, next.
Alright, so hi guys. I'll be presenting on some interesting facts about galactose. So first of all, galactose as prebiotic. So I'm sure you guys have heard about probiotic, but do you guys know what is prebiotic? Okay, so prebiotic actually means it can induce the growth or activity of beneficial microbes in the gastrointestinal tract. For probiotic, is the additions of microorganisms like beneficial microbes to your intestinal tract, but prebiotic is induced growth. The second one is lactose intolerant. So there are actually people in the world that when they drink milk, they will suffer from conditions like diarrhea and or bloating, and they will feel very uncomfortable. It's actually due to the fact that their body does not produce enough lactase. So we have, I'm not sure if you have heard of this, but I've never drank it before, even though I always enjoy farm fresh milk. It's a type of milk called lactose free. So the producer of this milk actually added the lactase into the milk and then break the lactose into galactose and glucose. Yes. And then the third one is galactosemia, galactose, which is also known as galactose intolerance. So galactose intolerance and lactose intolerance is two different things. Galactose intolerance is much more, the condition will be much more disastrous because the body cannot digest the galactose and then convert it into a glucose and use it as an energy source. So if the infant suffer from galactosemia, the galactose will actually build up in the blood, and then this is actually a type of metabolic disorder. As I said just now, we cannot produce energy from galactose, and it's normally due to the a type of liver enzyme that is named as galactose 1-phosphate uridine-transferase, GALT, that is missing or non-functional. Yep, so that's it for the interesting facts about galactose, and I will end our presentation here.
Okay, thank you. K2G1, can we have the second presentation first before we ask question? Second presentation from K1. K1G2, right?
Yes, yes, wait.
Okay.
Yes.
Who is Binturo Hitam just now? You have microphone problem.
Sorry?
Who is Binturo Hitam just now?
Azik.
Azik.
Oh, Aziz. Abang handsome. Actually, I can't remember Haziq face. Okay, so let's get to K1G1. K1G2. Yeah.
Nampak ke?
No.
You guys see?
On the way.
Yes, you can see.
Why I cannot see? Why? Where are you? The slide. Am I the only one? I cannot see the slide now.
Sekejap.
Oh, di manakah kamu slide?
Sekejap. Dah nampak ke screen?
Oh. No,
Nampak ke?
okay. Nampak.
Nampak dah. Okay, we from K1G2 will be presenting about galactose. So we're going to go for our first slide.
Can you make it slideshow, please? Make it bigger.
I did make a slideshow right now. It takes time, I guess. Can you guys hear me?
Fatia belum tekan slideshow.
Dah? Belum ke? Dah tekan dah. Dah?
Belum.
Belum. Baik. Dah lah. Kenapa? Sekejap, stop presenting.
Try again.
Yeah.
But yeah, right? You are the one who are going to share screen, right?
Yeah. Okay, I'm sharing the screen. Nampak ke? Nampak.
Nampak tapi blur.
Okay, slideshow.
Tak clear.
Gelap masa depan
Fatia boleh tak?
I can see nothing.
Kenapa?
Are you okay?
Kenapa blur? Blur sangat ke?
Okay dah. Dah clear
Dah.
dah. Ah.
Better blur rather than nothing. Okay, sebab masa depan langsung tak nampak masa depan. Okay, let's just proceed. K1G2.
Okay, so I will presenting on what is galactose. It is a simple sugar which belongs to simple carbohydrates. It is an aldohexose monosaccharide with chemical formula of C6H12O6, similar to glucose structure except that the orientation of H and OH on carbon 4 are exchanged. So what is an aldohexose? It is a monosaccharide that contains 6 carbon atoms and an aldehyde group. So on the left picture, this is the structural formula, and this is the 3D structural formula. So on the right side, we can see a structure of galactose and glucose. So galactose we can get from the hydrolysis of lactose. We can get galactose and glucose. As you can see on both of them, they are quite similar but not quite, because on the fourth carbon, 1, 2, 3, 4, on the fourth carbon, on galactose, the hydroxyl are projected upward and hydrogen are projected downward, while on the glucose, it's the other way around. So I think that's all for the first slide. Not see the slide.
Ada orang tak boleh.
What happened, Fatia?
Fatia, next. Dah next dah.
Next, dekat kami tak next ni.
Apa? Saya tak ada pula masalah.
Aduh.
Kenapa dia tak
You
next?
can see your third slide. You're still in the second slide.
Just stuck there.
Okay,
Tak ada.
anyone who has slide other than Fatia? Okay, now we are in the third slide. Okay, carry on.
Kena pergi.
So now we continue to the classification of galactose. So first, galactose is a monosaccharide, as we all know. And next, galactose is not an essential nutrient, which means that we do not need the galactose from food to be healthy, because galactose can be synthesized in the human body from glucose. Next is galactose is also an aldose and hexose, and the melting point of galactose is 167 degrees Celsius, and the boiling point of galactose is 500 degrees Celsius, and lastly, galactose is soluble in water.
Okay, next is the structure of the galactose. As you can see, the right side of the slide, we put there are two structures, which are D-galactose and the L-galactose. What is the difference between those two? It's because for the D configuration, the hydroxyl group on the carbon 5 is located on the right side of the Fischer projection, while the L configuration.
What happened?
Hello?
I can't hear you. Adeline.
Hello?
We can hear her. We can hear you, Doctor.
Doctor, we can hear her actually.
We can
No
hear her.
slide, no sound. What happened?
Got sound.
Doctor?
Is everyone seeing the slide or not?
I see the slide. I see the slide of galactose classification.
Okay, you can hear. Okay, as long as you can hear, let me just imagine what you are trying to say. Because I hear you, I cannot see the slide. But someone, Okay, is someone recording? I mean, the host? Who's the host just now? Okay. As long, Gianti, right? As long as you can have it, then we can see it later. Okay. So just proceed. I can see from the slide later on, from the video later.
Okay. Um, for the L configuration, why it is named as L galactose because the hydroxyl group on the carbon 5 is located on the left side of the Fischer projection. That's all.
That's it.
So we proceed with the source of the galactose. So the major dietary source of galactose is lactose itself, because mostly we can found lactose in all animal meat. So galactose can get actually from the hydrolysation of the lactose. So once lactose be hydrolyzed by the enzyme of the lactase, that will give the lactose and glucose. So in the membrane cell level, galactose it is a part of the glycolysis and glycoprotein. So I proceed with my members.
So the next one is galactose important. Fatia didn't change.
Important of galactose. Supposed to be function first.
Function.
Who present the function?
Fatiha, the slide doesn't change. Change.
Now?
Okay. Okay. Okay, so the next is function of the galactose. So as we all already know that it serves as key of source of energy. And the next one is it also helps in removing neurotoxic compounds from the brain in patients who are suffering from hepatic encephalopathy or eczema disease. Hepatic encephalopathy is actually dysfunction of liver. The next one, galactose also act as prebiotic, which actually been explained in the previous group, provide beneficial effect in the gastrointestinal tract of human, and it not only by stimulating growth of selected membrane of the intestinal microflora. Microflora is organism that live inside of human body or animal body, such as bacteria, algae, or bacteria, archaea, no algae, archaea, or fungi, but also through their anti-adhesive activity. And the last one, it serves as a substrate for cerebrocyte, kelocyte, and mucoprotein in the brain and nervous system, which also support its neural and immunological role. That's all for me.
Nampak ke?
The importance of characters.
Are you done, this group?
No.
No.
Okay.
Okay guys, see the slide.
It doesn't change.
No. Doesn't change.
Yeah. Okay dah.
Okay, so we move to the importance of galactose.
The first important is galactose plays a potentially useful role in removing this neurotoxic compound from the brain in patients suffering from hepatic encephalopathy or Alzheimer's disease. Second important is galactose is a major nutrient in normal newborn infant and serves as a substrate for energy production and fuel storage and a regulator of carbohydrate assimilation. The third one is galactose is an important constituent of the complex polysaccharide, which are part of cell glycoconjugates, key element of immunological determinants hormone, cell membrane structure, endogenous lectins, and numerous other glycoproteins. And the final one is galactose is incorporated into galactolipids, which are important structural elements of the central nervous system. That's all from us.
Yes.
Okay. Thank you, this group. Okay. Yeah. I think I don't know the most group which has drama in terms of the presenting the slide. I can see sometimes the voice is there. Most of the time I lost the voice. Okay, never mind. As long as you have recorded this, I think for galactose, it's just like similar to glucose. And then from Kalista group just now, you have differentiated this between these two. And then, but still, both of these group are lacking of detection. How do we detect all these two carbohydrates, right? I know that galactose has the aldehyde group compared to fructose, and then how do we detect in the lab? What is the common things being used? I mean, chemically detection in the lab. I think you have learned a bit during your matriculation or diploma, or maybe SPM about how to detect carbohydrate in the lab, right? What is the name of the test?
Benedict test.
Yeah, so at least when you mention about Benedict test, I would expect all this from the monosaccharide thing will highlight why, what is so important from the structure wise, how carbohydrate can be detected using Benedict, and then the Benedict test is sensitive for both or only for galactose or only for fructose or what? So yeah, we need to look at into the detail how this can be used. I mean the detection method in the lab. Okay, and I think we can go to the disaccharide now. Can we start with lactose? Lactose team?
Okay, doctor.
Lactose from which group? I don't mind. Or maybe K1 again. We start with K1.
K1G3. Hello. Yes, yes. Can you all see the screen?
Yes.
Okay. Okay, hello everyone. We are from K1G3. We would like to present you all about lactose. So the definition of lactose is a sugar present in milk, and it is a large molecule that is made up of two smaller sugar molecules. Okay, now to pass to Vartini to explain further.
Okay, hi everyone. So lactose has a molecular formula of C12H22 and oxygen O11, and also with a molar mass of 342. It has a density of 1.525 gram per cm cube, and also it appears as a white solid at room temperature. So now we see the condensation process. So galactose produced from the condensation of lactose produced from the condensation of galactose and glucose with the removal of a water molecule to form a beta 1,4-glycosidy linkage. Okay. So, there's actually two lactose here, alpha lactose and also beta lactose. So these two lactose can be differentiated by the position of OH group at the carbon 1 of glucose molecule. So, for example, when an alpha glucose molecule bonded to a galactose, it will form alpha lactose. So, alpha glucose means the position of OH pointing downward at the carbon 1. So, this one same goes to for beta lactose. So, for the beta glucose, the position of OH group pointing upward at the carbon 1. Okay, that's all from me.
Next is the classification of lactose. Lactose is a disaccharide composed of monosaccharide, glucose, and galactose. Lactose usually present in milk produced by cows, sheep, and other mammals. Next, the physical properties of lactose or the appearance is it is white, solid, odorless, and sweet tasting. As we have previously know that lactose occurs in two isomeric form, alpha lactose and beta lactose, and it is expected the beta lactose is sweeter than the alpha lactose. Next, when we look at the lactose content in milk, in human milk, which is the breast milk, the lactose contains about 7%, while in the cow milk it contains about 5% of lactose. And the solubility, lactose is very soluble in water and slightly soluble in ethyl alcohol. That's all.
Can you hear me?
Yes.
Okay. For the naming, actually lactose often called milk sugar because actually it is directly come from the word lac, which in the Latin it means milk, and the suffix os used to name sugar, so it is directly
Who's
called
speaking?
milk sugar.
I can't hear you clearly. Your voice like really far, far, far away.
Can you hear me now?
Yes, we can hear you.
Yeah, can you speak
Okay.
louder a little bit?
Okay, for the lactose, it is called milk sugar because the word lac comes from the Latin word which means milk, and the suffix os is used to name sugars, so it is directly called milk sugar. And for actually the IUPAC name is beta galactopyranosyl 1,4-D-glucose. The one arrow 4 shows the linkage of beta galactose, which bonded with the carbon 1 is bonded with the alpha glucose at the carbon 4. So and another name for the lactose is lactobiose. The lactobiose is actually a noun of lactose. Next.
Okay, I will be talking about the sources of lactose. So lactose is found mainly in milk and dairy products such as cow's milk, goat's milk, yogurt, cheese, and ice cream. It can also be found in ingredients in food like bread, cereal, and salad dressings. So a few of the sources that we have here is whey and curds. So whey is a nutritious protein-rich liquid expelled from curdle during the cheese making process. Curds and whey is a genetic name given to curdle milk, which separates into lumps of cheese called curds and liquid called wheys. So next is bread, milk and buttermilk, yogurt, ice cream, and food.
Okay, so next we move on to the function of lactose. First, cell can convert the component of lactose in the carbohydrate glycogen. So we know that glycogen is a residue of glucose, and monosaccharide for the galactose is glucose.
Monosaccharide for lactose is glucose and galactose. So from this, it can provide a supply of sugar that will help a lot, especially for the Muslim to fasting during the month of Ramadan. Okay, next, add in the absorption of calcium and phosphorus. Not only that, it can also absorb other minerals such as copper and zinc during the infancy. Infancy is the earliest stage in the childhood. And then thirdly, it can support the growth of friendly bacteria in the human gut. We know that lactose can be used in the intestinal microbiota. Intestinal microbiota is a microorganism that lives in the digestive tract. And lastly, the galactose carry a role for the development of brain and the nervous system. So how? Actually, the galactose will serve the substrate for the cerebrocyte, gangliocyte, and the mucoprotein in the brain and nervous system that will support the neural and immunological role. So cerebrocyte is a complex lipid in the sheath of nerve fiber, while gangliocyte is the lipid that present in the grey matter of the human brain, and the mucoprotein is actually the glycoprotein. So that's all from me. Thank you.
We have added an extra info that is about lactose intolerance, where a person's body is unable to digest the lactose, which is found in milk and dairy products. Why did this happen? It is because their body produces less lactase enzyme, which breaks down the lactose molecule. Someone who actually has this lactose intolerance usually will have stomach cramps, bloating, and most of the times diarrhea. Who will get this lactose intolerance? It depends on ethnic background. People of Asian, African, and Native American more likely to develop this at a young age. Other problems with the digestive tract, which people who have inflammation at their upper small intestine will have reduced level of lactase enzymes. For the medicine, certain antibiotics can trigger temporary lactose intolerance. And for the infection, some kids can develop a temporary lactose intolerance due to infectious diarrhea, but it usually improves after a few days or weeks. For the age, as people get older, their bodies usually stop those intolerance over time.
Okay, next we'll be talking about the symptoms. So people with lactose intolerance may have a variety of symptoms. It all depends on how much dairy or how many milk-containing foods the person eats and how little lactase the body can produce. So usually within 30 minutes to 2 hours after eating, someone with lactose intolerance will experience nausea, stomach cramps, bloating, gas, and diarrhea. Because many people may think they are lactose intolerant when they are really aren't. So it helps to see a doctor who can diagnose the condition correctly and advise you on ways to manage it. So there's two ways to diagnose lactose intolerance, which is hydrogen breath test and endoscopy. So doctors can test for lactose intolerance by using the hydrogen breath test. Normally, very little hydrogen gas is detectable in the breath. However, undigested lactose in the colon ferments, which means it breaks down and produces various gases, including hydrogen. So the hydrogen breath test will help us to diagnose either intolerance to sugars, or as such as lactose intolerance, or SIBO. SIBO is a small intestinal bacterial overgrowth. The test measures how the amount of hydrogen present in your breath changes over time when you consume a sugar solution. There's usually very little hydrogen in your breath, and having a higher level of it usually indicates a problem. So next is endoscopy. Everyone should know what endoscopy is. So if your doctor thinks you might be the doctor can find out if you're able to digest lactose by testing for the presence of lactase with an endoscopy. During this procedure, the doctors will view inside your intestine by inserting a long tube with light and a tiny camera on the end of the mouth. At the end, into your mouth. And the doctor can take tissue samples and pictures of the inside of your gut and look for clues why you have been having problem with what you're eating.
And the amount of lactase enzyme can also be measured from tissue samples. Okay, next.
Okay, so I'll be talking about tips to deal with lactose intolerance. Okay, people who have lactose intolerance, they can consume lactose-reduced or lactose-free milk. Lactose-free milk is, you can see there are small soy milk, there is almond milk, and there is rice milk. So there are lactose-reduced foods, which, for example, there are honey, sugar, syrups, jellies, and more. And also, moreover, like with lactose intolerance people, they can take lactase enzyme supplement such as lactate before eating dairy products. So they can take the supplement before eating dairy product. In Malaysia, there's a supplement in the brand of Nature's Way. It is lactase enzyme supplement. Okay, and next is when eating lactose containing food, they can eat other non-eating lactose food. So for example, like if you're gonna drink milkshake, so they can eat with the sandwich together so that it will make the symptoms slower. We can avoid the symptoms, and also the digestions can be slower. And here we see there are drink juices fortified with calcium. Fortified with calcium means that the juice is strengthened. Uh, the juice contains more calcium. So, like for example, there's a famous drink usually fortified with calcium is normally orange juice, which now there's a orange juice drink that we all know, which is known as Tropicana. So Tropicana has their own has a juice which is called Tropicana Calcium Boost. So people with lactose intolerance, they can drink this juice, and also they can eat yogurts that contain active culture, which is easier to digest. Active culture means there's a living organism. So they will living organism, which is in this yogurt case, the living organism is lactobacillus and streptococcus. So these living organisms will be inside these yogurts. So it will be easier. It will uh, it will make the process easier to digest lactose. So that's all from us. Thank you.
Okay. Thank you. Don't know which group just now. K1, right? We are from K1, right? Okay.
Yes.
So now, can we have our last presenter? I mean, we don't have much time already. Can we have our last presenter from K2 talking about lactose? K2, please.
Hello, Doctor.
Okay.
Can you hear me?
Yes. Just share your screen quickly because we have 3 minutes left. You are not sticking the time. I told you it should be 10 minutes maximum. All of you like too many things want to share.
When Doctor, I'm waiting for my friend to present the screen.
Okay.
Hello. Nampak tak slide?
Tak nampak.
Ah.
Okay. Why so small in the middle of a
Right? Have you shared the screen?
Can you make it bigger? It's so small.
Yeah.
What happened, Badri? Nombor 1 dah baju.
Wait lah. Wait. Sekejap.
Banyak betul bunyi WhatsApp masuk tu ha. Glamour betul.
Okay, nampak tak?
Yes. Okay.
Yes, sir.
Okay.
Okay. So I gonna go fast. Okay. So Assalamualaikum warahmatullahi wabarakatuh and good evening. Okay. So I'm the representative for K2 G7 and I'm gonna present about carbohydrate, which is lactose. Okay. Next. Okay. So for the definition of the lactose. Okay. So lactose is a large sugar molecule and it is made up of two smaller sugar molecules, which is for the first one is the glucose and the second one is galactose. So why it is two smaller sugar molecules? Because of, as we all know, so glucose is a monosaccharide and also the galactose, and so lactose is the made up of two, both of them. Okay, and next. So next for the structure, okay, so this is the structure. Okay, so we can see at the right, at the left. So the left side is actually the galactose, where there is C4 epimer of glucose and beta D galactopyranosyl unit, and the right side is the part of glucose, where it has B enomer of glucose, D agyl con. Okay. So the connection between galactose and glucose via the beta 1,4 glycosidic bond, which is we can see at the below figure. For galactose, we label the carbon 1, the first carbon, and for the glucose at the fourth carbon. So between the first carbon for galactose and between the fourth carbon for glucose. So there's the beta 1,4 glycosidic bond. Okay. So this is for structure, and next we go for classification. So classification for lactose, if we recall for the definition, so it is made up of two sugar molecules. So we can conclude that lactose is a disaccharide, and disaccharide is a class of sugar molecules that contain two monosaccharides, which is glucose and galactose. And lactose also is a sugar that composes via glycosidic bond between galactose and glucose subunits by the formation of beta 1,4 glycosidic bond. Okay. So next. So for the naming, okay. So for the naming, for the IUPAC name, so it is called as beta D galactopyranosyl 1,4-D glucose, and we can also, for the other names, milk sugar, lactobiose, or we can call it as 4O beta D galactopyranosyl D glucose. Okay. Next, for the sauce. Okay. So dairy products. So dairy products, we list 3 examples, which is milk, yogurt, and cheese. Like one of our classmates said just now, cheese meleleh. So this is cheese. Okay. So next, so this is the sauce, and lastly for the function and importance. Okay. So lactose. Lactose enhance the absorption of calcium and other mineral in infancy, and lactose also used by the intestinal microbiota as a source of nutrient, and it also acts as immediate energy, and lactose can be break down by lactase to form galactose and glucose. So the breakdown process actually occur in our small intestine, where the lactose, there's enzyme which is lactase that will break down the lactose, which is disaccharide, to simpler sugar molecules, which is galactose and glucose. For what? For easier to be digested. I think that's all. That's all from us. Thank you.
Okay, thank you K2G7. So both of this group has presented about the lactose, right? Okay, I wonder, how do we detect lactose basically in the lab? And then how can we differentiate? Can we differentiate between lactose and fructose or galactose or glucose in the lab? Like, is there any specific test can be used?
Yes, betul. Wait, I think. Sekejap.
Test of lactose.
Yeah, there's two. First, hydrogen breed test, and another one, yeah, can first hydrogen breed test.
The second one is lactose tolerant test.
Yes.
How do we, and then which part of the lactose being detected?
For the lactose tolerant test, we will get the blood test to measure the amount of glucose in the bloodstream. If the glucose levels doesn't rise, it means that the body is properly digesting and absorb the lactose with meat.
Okay, that means you are measuring the product, not the lactose itself, right?
Oh yeah.
Yeah, so yeah, in case we just want to know solely on the lactose, you know, like we don't want to. So as for now, you cannot find anything how to detect the presence of lactose, solely for lactose, something like that. Are you saying that way? And then what is the source of lactose? Just now, it is so can our body, human body, synthesize lactose? I mean, yeah, lactase, or is it because of the microbiome in our GI that providing the lactase? Which part that contribute more to lactase enzyme? Can the human produce lactase? The question, or normally we are not human is not going to produce lactase, but it is provided by the microbiome that live in the gut. What do you think?
I think for the lactose can be produced in our body, but in a small amount. So the E. coli, I think E. coli is a microbiota will produce lactase.
Okay, so that means you are suggesting that E. coli basically supplying the lactase to the human.
Sorry, it's not supplying lactase, but it's break down the lactose to how to say this.
How E. coli break down the lactose?
Using lactoferron system metabolism.
Okay, that means you are suggesting that E. coli is consuming the lactose in the human body as one of the carbon source, so that it can do the fermentation, right?
Yes.
Is it that way? Okay.
Yes, that's right.
The way how the body break down lactose. Okay, please have a look at it. Okay, I like the idea of you say, you know, like the people, I mean a few of you talk about prebiotic, right? Prebiotic, and then again when you get older, and then the number of the microbiome reduce due to many factors, and then one of them may be because of the antibiotics that you are taking when you're not feeling well, or do you have problem with the you know, all these microbes. Okay, so what happened when you are taking too much antibiotic or something, you basically not only killing the bad bacteria, you are also killing the good bacteria, like lactobacillus acidophilus. You know, we have bacillus casei in your stomach, and then yeah, we need this kind of that's why when you get older, the numbers of the microbes become less, and then we need this kind of prebiotic to support the growth of the probiotic. So if you have enough probiotic but not enough prebiotic, it won't be something balanced. You know, you need to take like every day the probiotic. So that's important of having prebiotic in your daily diet. Okay, so if it is not because of the MCO, maybe we can arrange the trip to Vitagen. Last time I did bring some students, the students to Vitagen company, so that we can have a look. This is how the probiotic, the cultured drink, cultured bacteria drink being made, and then yeah, they are willing to accept all the biotech student from UPM, so that we can enjoy free Vitagen drinks, and then yeah, that's a really good experience, but not going to happen this few years time. Okay, so later what you need to do, just each group need to highlight, I think whatever you have now, like fructose, galactose, lactose, three group have presented, except we have sucrose, starch, fibers, glycogen, and chitin, right? For the next presentation on Wednesday, we will do it, and then we'll finish it hopefully within 1.5 hours, so that after that we can focus on the SCL, and then you are welcome to try if you want to have mock. Okay, so you can also send the slide that you have now, send to our Discord general channel with the improved version. Please try to make it not too wordy, and then let's reduce the typo stuff and everything. Okay, I think that's it. We exceed for 12 minutes already. So yeah, do you have anything, because we haven't completed the overall presentation? If you have anything, you can just text me in the Discord channel. We don't want to prolong this session. Okay, guys, are we good?
Yeah.
Oh, you're gone.
Yes, doctor.
Yes.
Yes, doctor.
Okay, see you guys next on Wednesday. Okay, bye.
Thank you, doctor.
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 Thank you.
Thank you, doctor.
Thank you.